So the speaker is Juan from Tsinghua. He's a PhD candidate there, has a background in both network security and mail security, and is going to tell us how, well, the sender policy framework actually sometimes fails in practice. Go ahead.
Okay. Hello everyone. I'm Chuhan Wang from Tsinghua University. It's my pleasure to be here to share our work on email security. The author is from Tsinghua University and a co-mail email company in China. The title of our work is BreakSPF, How Shared Infrastructures Magnify SPF Vulnerabilities Across the Internet. So how to use it? Okay, that's good. As we all know, email is one of the popular services on the Internet. Meanwhile, email services is also one of the oldest application on the Internet. The first email is signed almost 50 years ago. I think it is older than most of us here. And now email services still plays a crucial role in modern communication, such as in the field of academic communication and business communication. Just because of the importance of email services has also become an important target for attackers. Nowadays, almost every email users are troubled with email phishing, email malware, and other kind of email attacks. Just among this kind of attacks, email spoofing attack is one of the common email attack techniques. Attackers will use a forged email sender to deceive the victims, since people are more likely to believe emails sent from familiar accounts. In fact, it's pretty easy to launch an email spoofing attack because the basic SMTP protocol lacks necessary authentication mechanism when it's initially designed. Attackers can impersonate arbitrary sender addresses to send spoofing emails. For example, as we showed here, attackers can claim the email is sent from alice@8.com or bob@8.com, or whatever they like. And it's difficult for receiver to distinguish which email is really from Alice. So recently, there are several important email authentication protocols have been proposed to solve this problem. So far, 3 protocols have been widely deployed. They are SPF, DKIM, and DMARC. The 3 protocols are designed from different perspectives and constitute an email authentication chain to authenticate all incoming emails. Today, our work mainly focuses on the SPF protocol. SPF is an IP-based email authentication protocol. It requires the email administrators to publish their SPF records on their DNS services. Email administrators can claim the IP addresses they will use to send emails in the SPF records, and the receivers can justify, based on the SPF records, and justify whether the email is really from the sender. So far, SPF has become the most commonly used email authentication protocols. About 70% of MX domains have deployed SPF. The adoption rate of SPF is significantly greater than DKIM and DMARC. The result shows that SPF plays an indispensable role in the email authentication chains. And many domains protect themselves from email spoofing attacks only relying on the SPF protocol. However, we found there exists some potential security risks in SPF. The vulnerable configuration is common in the real world. We found there are over 50% of domains which list more than 65,000 IP addresses in their SPF records. Obviously, for most domains, they don't need such a large scale of IP address to send emails. Besides the vulnerable configuration, the trust model of SPF itself is also weak. The only identifier used by SPF is the IP address, which means anybody who owns the IP address can send spoofing emails on behalf of this domain. What's even worse, in the era of cloud services, centralized email service and centralized SPF deployment are common. In this way, a single IP address may be able to send emails on behalf of thousands of domains, which violates the assumption of SPF. All these potential security risks in SPF provide opportunities for attackers to conduct email spoofing attacks bypassing SPF. Previously, studies only focused on SPF records and pay less attention to IP availability. We believe it's not enough. For example, it's difficult to judge such an SPF record is vulnerable or not, only by checking the record itself. If you can obtain an IP address in this IP range, you can know that this SPF configuration is vulnerable. So our research goal is to evaluate the potential systematic security risk in the SPF deployment and found domains which exist SPF vulnerabilities. In this work, we have designed an evaluation framework called BreakSPF, which includes 6 steps and has 3 main features. First, it will measure the deployment of SPF throughout the SPF dependency tree, and second, it will collect IP addresses from shared infrastructure automatically. And third, the framework can identify SPF vulnerabilities with convincing evidence. Next, I will show the detailed steps of BreakSPF framework. We first started with a large-scale collection of subdomains from passive DNS data, where our domain data set involves more than 7 million domains. And the second step is SPF scanning, because the redirect and the include mechanism are commonly used in SPF records. So each SPF record can establish this dependency relationship with other domains. We call it SPF dependency tree. To evaluate the status of SPF deployment more comprehensively, we need to traverse the tree structure recursively. And the third step is domain processing. We need to establish a reverse query mechanism for the SPF dependency tree. We need to reparse the SPF records and traverse the SPF dependency tree to record each node's ancestor. And we also process the results of SPF scanning and perform some necessary analysis. In this way, we can know which domains are affected by a vulnerable SPF record. And the fourth step is database building. It's an important step of the framework. We parse each SPF record and extract IP addresses to create mapping from IP addresses to their corresponding domain names. We build a database called SPF Reverse Database. Considering the IP address space is too large, we optimize the storage model using a tree structure. We converted an IP address block into a 32-bit integer, and we use the integer as the key of the database to store the domain name and the CIDR prefix lines on this key. And for more algorithm details, you can refer to our articles. The first step is IP collection. Fortunately, in the era of cloud services, there exist many ways to obtain IP addresses, such as cloud service, proxy services, serverless functions, CI and CD tools, and CDN services. However, many shared infrastructures listed here only support HTTP transmission. So the question is that if we can utilize these shared IP addresses to send emails. The answer is yes. In this work, we proposed a novel cross-protocol email spoofing attack. This kind of attack leverages the similarities between HTTP and SMTP protocols. As shown in the picture, you can see that these two protocols are both text-oriented protocols with very similar structures. And besides, the email services also have high robustness, which can receive and ignore identify SMTP commands. Due to these mentioned factors, we think it's possible to send emails where HTTP requires packages. Based on this idea, we try to embed SMTP data into the HTTP packages and send them via CDN services or HTTP proxies. Luckily, we made it. Email services can receive emails signed in this way, and which means attackers also can perform email spoofing attacks by using HTTP services. Finally, we propose 3 types of cross-protocol email spoofing attacks, and these attack techniques are suitable for different attack scenarios. With the help of cross-protocol attacks, we obtain a total of more than 87,000 IP addresses from above 5 types of shared infrastructures. The collected IP address shows excellent geographic distribution characteristic, which comes from more than 4,000 AS number and covers 181 countries. And it's worth noting that the cost of obtaining an IP address is very low. The average cost for per IP address is less than 1 cent. Then we've used this IP address to access the web API provided by our framework, and our framework will identify if current IP addresses are exploitable or not. And the last type is email spoofing. Attackers can send spoofing emails to arbitrary victims and will share the infrastructures on behalf of vulnerable domains. In our experiment, we conducted a large-scale experiments based on the domain site and the IP addresses we collected before. And our results shows that SPF vulnerabilities are prevalent on the internet. The results shows that more than 23,000 domains are influenced by BreakSPF attack, with 23 of them belonging to the top 1,000 domains. And our results also uncover managing SPF records is a challenging task, even for even well-known technical companies such like Microsoft and Tencent will also make mistakes. In recent days, more and more domains are willing to host their email services to professional email providers. Our further analysis revealed that the centralization of SPF deployment magnifies SPF vulnerabilities. We find a single IP address even could influence thousands of domain names due to the centralization of SPF deployment. Here is the top 10 domain group influenced by only one IP address. I think the misuse of the include mechanism has resulted in this phenomenon. In our experiments, we found that email providers also used cloud services to host their services. However, when the configuration of email providers is vulnerable, the situation is even worse. For example, we find a misconfiguration comes from an email provider. Their SPF records contained a large number of IP ranges from cloud services like Alibaba Cloud that doesn't belong to them. So attackers can easily obtain the corresponding IP addresses from Alibaba Cloud services and send spoofing emails. That means all clients of these email providers are vulnerable to BreakSPF attack. And here I want to show you an example to show the feasibility of BreakSPF attack. We sent spoofing emails to our Gmail account impersonating admin@meeting.tencent.com. Tencent Meeting is a famous video conference software in China, like Zoom, and provides services for millions of people. And BreakSPF attacks permit attackers to send emails that pass SPF and DMARC verification. As you can see on the user interface of Gmail, the spoofing emails we send pass the verification of SPF and DMARC. Finally, we made a responsible disclosure to all vulnerable domains we found in the experiments, and we tried our best to contact these domains where SRC and email contact. Before we submit the paper, almost 8,000 domains had already fixed their SPF vulnerabilities. And to conclude, I think our work highlights the vulnerabilities in the email authentication chain and demonstrates the shared infrastructures can magnify this weakness. We hope this research will raise awareness in the technical community regarding the security of the email authentication chain and the issues caused by shared infrastructures. That's all today, and thank you for listening. I'm ready for any questions.
Thank you. Already see somebody, name and affiliation and your question.
Hi, I'm Barry Liba. I chaired the DKIM working group in the IETF, and I currently chair the DMARC working group in the IETF.
Okay.
Thank you for this. In the development of the DMARC standard version spec, which it's right now an experimental specification, we are deciding whether to have some mechanism in DMARC to say, don't pay attention to SPF, only use DKIM because of these kinds of vulnerabilities. So I'm very pleased to have this kind of research out there for us to reference. And I would like to get your permission to send your paper to the working group mailing list.
Actually, I'm also in the mailing list, and I'm focused on the topic.
Can you go closer to the mic?
Yeah.
You need to go
Say that on the microphone.
back to the microphone.
Okay. I'm also in the mailing list, yes. And read your discussions about this topic.
Okay, good. Thank you very much.
Thank you.
Okay. More questions? Otherwise, I have a couple. So I've also done work in email security, and
yes.
I have kind of scratched my head in understanding what the hell is wrong with people. Do you have any thoughts on, you said there were 8,000 domains for which these things were fixed, right? Are these issues related to legacy, people moving away? Is it misunderstanding of what the mechanism does? Do you have any intuition on why this is even happening?
I think for people, the reason for the vulnerable SPF configuration is often for the convenience for configuration. They want to configure a large subnets to make sure that their emails will send from the correct IP address and will not be rejected by other email addresses. So this sort of the robustness, so they configure in this way. This may work in the maybe 20 years ago. People don't have access to IP address from many methods. So even you configure your SPF records a little broad, so it doesn't matter. But however, in these days, I think it causes serious problems.
Okay, and you said that you had these about 8,000 domains that were fixed. Were these, let's say, rather individual fixes? So did 8,000 domains update their SPF records? Or was it more like the example that you showed there where you have this hierarchy? So you have domains that rely on an external service, which includes 3 other external entries. So how did these fixes happen, let's say?
I think both situations are included. Some are individuals' domains, and we send emails to them, and they send for us a report, and they remove the necessary IP address in their list. And some of them are email providers. If some of the email providers remove the vulnerable configurations, there may be thousands of domains will not be vulnerable.
Thank you very much. I think also it would be interesting to do this experiment again in a year to just see how many legacy IPs are then again added in there. But yes, in the interest of time, let's thank our speaker one more time.